Hello everyone, I'm really happy to be here with you today, and let me start with a short introduction of our company. We have already 44 years of excellence. We work and have 76,000 of consultants. We work in 40 countries and more than 400 locations. And we have a business model involving local proximity, and we try to be as close to our clients as possible. For each client, we do surveys and interviews in order to understand exactly their business need and what they are seeking, what are their business aims in the nearest future. And we try to be there for them to help them reach their business targets. So besides that, as you can understand, we have a big network of our clients, and we have an opportunity to get the best practices and to know newest industry trends in the market. And we also can offer our clients the best solutions that are available in the market. Besides that, we always keep track of various IT trends. We keep track of solutions, of devices, of different services, and we try to understand what are the new things that we can bring to our client in order to perform better and optimize their organization. So during the long period of time, we have identified KPIs for industrial companies, and those KPIs in most cases are quite similar. So we have on one side finance, and each company of course wants to earn more. On the other hand, we have operating and maintenance manufacturing costs. So for industrial companies, we have quite expensive equipment in our facilities to produce our product or service. So we cannot just simply cut the costs, and we have to consider some other important KPIs as well. So for example, availability of our equipment, because we want not to have any downtimes or reduce them to zero. So we want our equipment always be available to produce our service or product. On the other hand, we would like our product or service be very good quality and get the highest efficiency possible. And besides that, for some, especially for some industrial companies, health and safety question is very important. And also as a company, we usually want to reduce risks. So today I'm going to tell you an example of one of our clients, which is natural gas grid operator. And for them, health and safety question is key importance. So this is the company, and the main equipment for them is the big network of pipelines. In their case, they have about 2,000 kilometers of pipelines of big diameter. And because it's a natural gas industry, for them, any failure and defect in pipelines is very, very critical, because any defect means leakage of gas and potentially could lead to explosion, which can mean, in some cases, even death of people who are in that area of explosions. So they would like to have zero defects, and therefore they decided to implement the best possible solution in the market, and introduced the modern inspection method, which is called pigging. So there is a device, quite complicated device with different sensors, which is called smart pig, which is put in the pipeline inside, and which helps to do the inspection from inside of the pipeline, and identify potential damage of the pipeline before it happens. So this method is part of predictive maintenance method, which is called PIMS, Pipeline Integrity Management System. So the company wanted to implement this solution to their work. So the target of the company was implementation of modern maintenance strategies, and growing from reactive and preventive maintenance applications only to predictive maintenance strategies, and evolve with their maintenance management strategies towards Industry 4.0. So before they started this work, they had some existing IT systems that they were using. So they had the pretty common package of applications. So finance management or ERP system, HR system, quite advanced documentation management system, also partly automated purchasing process, and the GIS system, which is also quite typical for grid operators because the equipment is distributed in big area, and there are some big distances between the equipment, so they had to use GIS system. And as you remember, for them the key target was to reduce defects of the pipeline. And of course, the important question is how they were managing the maintenance of the pipelines before. So unfortunately, they did not have any specified program for service and maintenance of their equipment. So they did something quite typical. They tried to use existing systems and put functionality that they actually needed to those systems. For example, they put some equipment lists with the unique ID codes into finance system, or they started putting technical documentation in their documentation management system. As well, for example, they tried to put some information in the GIS system about at least pipelines and some technical characteristics of the pipelines. However, those systems did not fulfill their business needs, and the most of the documentation was still managed in the paper format, and in some very rare cases in Excel. So as you can understand, this is not an efficient way to deal with information at all. So the biggest challenge of our project when we came to this company was manual part digitization and converting it to electronic format. So what we did, we basically took the whole package of the documentation. We analyzed what they really need, what should be put in the system. And we basically converted this unclassified documentation into well-structured way and put each parameter that is important for us in particular field in the system. So in the end, we collected everything that they need in one place. So we basically changed from the beginning the way they operated. So instead of filling in paper documentation, they started to work directly with the program and started to fill all information about equipment and maintenance directly there. So as a result, they started having all data in one place. Also, the system brought them the functionality. In their case, they were using IFS applications. So the standard functionality of IFS system like system parameters, user roles, statuses, automated workflows helped them to deal with this data that they had. And as a result of this data and processes, they were able in the end to get this good quality analytics online, for example, maintenance plans and schedules. They were able to extract data and to put in the form of operational reports instead of manually filling in the reports by hand. Also, the managers got the possibility to keep track of ongoing KPIs and keep track of ongoing key processes of the company. So in parallel to this project, which was quite complicated itself, a few collaborations and integrations happened. So besides IFS application implementation, there was in parallel PIMS system implementation going on. And those two systems implementation triggered changes in existing GIS system as well. So now a few words about those integrations. So the target of the client was to implement this preventive maintenance PIMS method. So they've chosen the program which actually does not have the storage of any technical data. However, it has all parameters required for data model for preventive maintenance calculation, and it has to take this data outside of the system, and then it gives back recommendations for preventive maintenance. So this data required for data model had to be stored somewhere else. So in our case, we had the originally GIS system, which had the pipelines and their components on different layers and their coordinates in GIS system. So also after creation of the new components in GIS system, they started to be loading in IFS system, and their remaining required data was filled in additionally on top of the information that was done in GIS. Also, after getting the full list of equipment, maintenance plans for this equipment was also stored in IFS system. So upon request for preventive maintenance model, all data has been loaded from IFS system to PIMS. So these were about 80 different types of equipment with their attributes, about 400 attributes, so quite a lot of data. Besides that, directly from GIS system, PIMS was taking objects coordinates, also required for location of defects. So as a result, after manipulating with the data model and after getting inspection data from pigging method put directly into PIMS system, the PIMS system returned defects information and planned work recommendations. So these defects were turned into fault reports in IFS system, and also work order planned dates were adjusted according to the PIMS recommendation based on current situation and current state of the pipelines. So also for convenience of the engineers, some integration was done and some data was taken from IFS to GIS. So these were active faults registered on the pipelines and their components. So engineers could open in the graphical representation on the GIS map, they could see what are the active faults now registered. Also for selected pipeline or piping component, they could see what were historical faults registered for this component. So this quite complicated system was also done together with IFS system implementation. So this project was quite complex, and during the project, quite a lot of steps and milestones have been achieved. So first of all, of course, remaining manual process digitization was completed. Also, technical data was collected, selected, and converted into the electronic format. Also, IFS system was set up and prepared for advanced data analytics for any future projects which could happen. And the one really big part, complex integrations between IFS PIMS and IFS GIS systems were created and programmed. Besides that, all integrations with all other existing systems were also done. So for example, integration between finance and documentation management systems and others. So which in the end helped to connect all existing systems of the company into one big system package. So we could say that as a result of this project, main target was achieved. So company was able to implement predictive maintenance method and move from reactive and preventive maintenance methods to predictive maintenance method using PIMS, and the IFS implementation project was really quite a huge part into achieving this target.